Hello everybody, welcome to my workbench. As you can see, I'm starting a new project. I had that box laying around for some time, and I was thinking by myself, well, what should put I in there? So I came up with the idea to put an impedance meter of it. I'm quite in the middle of that. It consists of 3 valves. That is the 6XG7 and an EZ41 and an EC92. As you can see, I put the power supply in there. I didn't connect it up yet, so I have my bench power supply to fulfill that function. As you can see here, I put some coils in there for it is an oscillator. Oh dear. The name will come in a minute. For frequency ranges I have here. Yeah. See if you can see that. Yeah, this knob here has 4 positions at a certain frequency. There's a Hartley oscillator, the name's come back, so it's a Hartley oscillator. Resonating between screen grid and input grid, so that's the advantage of it, very stable. So that's very important that it is stable. So I put that resistor a bit aside up here. That should be right. Anyway, as you see, it is still loose all, and I'm just in the process of connecting everything up. So I have here the connection to the input grid, and the other connection on this side here goes to the screen grid. So anyway, and then in turn will be tapped to our EC92. And that in turn will give me the high frequency power to adjust my tuning capacitor to measure the self-inductance from a little coil like this resistor coil you can buy. You can see him here. This is 560 microhenry. So you can put that in between here, and then you can measure that. So that's the intention of this meter. Anyway, I know I have another one here that can do capacitance. Yeah, as you can see, the leads are on there. Here's 3.5, it's even more if you want to. Anyway, and you can do also a coil. Spool is a coil. You can measure that coil. I can show you that. So just make sure that you can see it. I take those leads off for a moment. I don't want them. Then we reset the lot. And calibrate them again. So, and I will take that little coil here. This one here, that's 560 microhenries. So I'll put that in between here. It's 569.4. See if you can see it. Yes, you can see it now. So that's exactly exactly the same thing as I'm building here. So and you will say, well, why you bother? I'm very fond of valves, and well, there are circumstances sometimes then our transistors or ICs, or how you call them, will give up the ghost and they won't function anymore in certain circumstances, especially when you look at the circumstances in the world at this point. So there everything can happen at the moment. So not that I'm afraid of that. Anyway, a Christian is not afraid, has no fear whatsoever. So because our Lord will save us when the time comes that far. So there's a hope a non-Christian doesn't have. So anyway, just leave it at that. Anyway guys, that's what I'm going to do. I'm going to build this this meter. I think it looks rather nice, and I'm sure it will function properly. Anyway, we'll try to explain it a little bit. See, if you have a frequency at a certain range and you have a capacitor at a certain range, and if you're familiar with resonance, then you know at a certain frequency, with a certain self-inductance and a capacitor, it will resonate at that frequency. Alright? So if you have a different, at this point you have a different self-inductance, then it will resonate also, but he will do that at a different capacitance. So we know the capacitance of this tuning capacitor, so we line that all up, put it on paper, and as we know, say it goes from 1 to 10, that's what, and it stays in between from 10, so actually 100. Then you can note that down, and you also can note down the self-inductance. That sounds complicated, but it's not complicated. Anyway, that's what I'm going to do, and I will continue now to finish off all my connections. I will get this on paper. Anyway, for the first range. The first range will be about from 300 microhenries till 4 or 5 millihenries. So that will be the range of the first range. The second range I don't know yet, so I didn't work that out yet. So I will do that with my power supply. So I don't with my bench power supply. I used that in the past as well. Well, I'll show you. You can see it. Alright, hold on. I will turn the camera now. Put them up a little bit. So there you go. That's my power supply. You have our filament voltage. We have a low voltage till 27 volts, 1.5 amp. We can do this. We have from 120 volts up to 350 volts here, with up to 80 milliamps, and I have a fixed voltage of 400 volts here. So I can switch that on from here. That's the switch from that part, and that is the switch from that part. The other is this only have to turn that up, that's all. Anyway, I can show you. It's on now. I can put it up, you can see. I can put up the voltage as high as I like. So, and this is the same goes for our high voltage. So yeah guys, that's what I will use to test my my meter, and I will keep you updated on how far I got. Okay. Welcome back everybody. As you can see, I put the top on. My paper or lists for the self-inductances are noted on here. I've fitted it down. Yeah. Now there are some few things that I have to mention, so I'll take it off. It looks rather nice that way. Anyway guys, first thing I have to tell you, I didn't proceed with that ECC85, with that crystal oscillator. It was too complicated with capacitance. So I have a very good experience with the pentode, so on an octal base. So I done that. So I'll turn them around. You can see I have a switch here with our little coils and the capacitor sitting here down here. You can see that. So and it's working very well actually. What you have to look for is for the dip from the meter. Oh yeah, the meter, I should have changed the meter as well. So that meter from 50 microamps, what was that? Yeah, or 5 microamps, so I beg your pardon. Well, I couldn't find a decent shunt to get that done, so I had that laying in the cupboard, in the box. I remember that, so I took it out and I put it in. And believe it or not, the meter had a short. So I had to fix that first. I did manage that. There was a short here on top and there was a short here on the bottom. So from then on the meter is working perfectly. So another point that was on the 50 microamps is that the meter was knocking on to the end and back and forth. So that doesn't happen now anymore. So I had a little test from the front here with some little coils what I have here. I tested the bottom frequency, the second one I tested, and I tested it on it. Oh, they're all working, so all the meter goes up to here. Can adjust the meter here. So I put it on a certain point. I put that coil in there, so then I adjust the capacitor, and I can read on the readout. I can see on the paper what kind of self-induction that is. Then you will ask me, is it accurate? Yes and no. It is accurate in the sense of you get near to the value what that little coil is. Point is, if you make an LC resonator, coil capacitor resonator, you only have to do approximately the self-inductance you need. So the thing is accurate enough to see if that is the case. So I will show you now what I've done. All the things are in. See if you can see this that way. Okay, you can see the valves. So that is a pentode valve. It's an EC92 and the EC41 for rectifying. The only thing you have to get this little wire, I have to go around the corner to solder it up here. So for the filament wiring, and I have to connect up the transformer here. It's not connected up yet, so that's the next thing to do. And then we have put the net lead on there, and then we have finished our meter. Anyway, it works perfectly, guys. I'm very satisfied and pleased with it. So, well, I think I will do a test for you when I have connected it all up. But I can assure you this works very well for a valve. And well, that's about what I have to say about it. You can see my my list here. Hopefully you can see that. Look a bit closer. I don't know if you for the shot for this in focus. I will try. Hold on. I will try. Once more. Now it is in focus. So you should be able to read it somehow. So you can see all the self-inductances are noted down. So that's what I was saying. As you can see, they are very close together. So you have approximately between here and there, you have a certain value. I tried that and it works out perfectly. So guys, that will be it for this video. I won't give any schematic. I think everybody who has a bit of knowledge should be able to build a meter like this. Yeah, the inspiration came from transistors, schematic from transistors. Yeah, that's about it. The only thing I can promise you is that I'll do a follow-up with some, if I have some decent values to measure, then I'll come back to you and show you how he works, but I can assure you he works perfectly. So anyway guys, that was it for this project, and I will see you in the next time. Welcome back guys. As you can see, everything is connected up, transformers connected up, the net lead is on there, so we are ready now for the test actually. I put up a schematic anyway, so I'll show you. That's just expose a little bit, let's see, hold on. Let's refocus just to make sure. And you can see the schematic how he's put together. So that's what he is, and we'll do some tests now. I'll show you how he works. Okay. Okay guys, as you can see, I put him shut the box, and we'll switch him on. And then we have some coils in here. The first thing I want to tell you is I can measure up to 1.75 microhenries. Beyond that isn't possible. I'll tell you why. This switch has only 4 positions. I should have actually one of 5 positions. I don't have that. So in the near future perhaps I will change that to 5 position. I have to change also this this paper here, so or my list has this. There's another one that is added on to it. So what I wanted to tell you is, if you go beyond 1.75 microhenries, then the harmonics start to play a role. So you get get a wrong reading. I can show you what I have to do. There it comes. Another point I want to make is, if you always have the ground frequency. You always have a resonance here, always a ground frequency. That's the strongest part of that wave. So what it actually comes down to is this meter, you can see here. If you get them up to a maximum point, the chances are that you take the harmonics with it. So the point is that you have a reading as low as possible. So I put them right there, and I take say coil. I know that coil, so the 560 millihenries of microhenries. I will get them out of here. So on. Let's have a look where he is. Oh yeah, I can see him. And I can show you what the meter does. At the moment it's getting resonance, you can see that. Hold on. That's our little coil. And we put them in those clamps here. I put on there. There we go. I think it is maximum capacitance and minimum capacitance. So I have to go. This is maximum capacitance. So I go to minimum capacitance. You watch the meter and keep turning, and there you go, your dip. Alright, so I have to move them up a little bit. The signal is quite strong. So let's put them up here, because you have a big amplitude here. This is a low frequency, and there's a very big amplitude here, so I can afford to do this. See, this is our dip, our maximum dip, and I can read out here, there's number 4, and number 4 up here is, have a look, 560 microhenries. That's exactly. This is exactly what it is. Yeah, That's exactly what it is, 560. So that the reading is correct anyway. So now I'll take another one. And that's a little coil I wound myself. You can see that. And that takes some doing to get this done. And I know about, I think it's in the 50-60 microhenries, this one. That is wound because of the capacitance, but I put on a resistor. So what you actually have to do is to wound this up to this side, that far around. Then you glue that, and then you go across every time. You swap across, and you get this this V mark on there. So you can see that where it is done. So, but enough of this. I will disconnect our little coil here. And the first thing I'm going to do is to put our meter back on the minimum. And I think, have a look, at 50-60 microhenries. This is the second band, so I put them there. So I go up. See, the meter drop down completely. I will leave it even there at the moment, so I get this off. Yeah, and I'll put this one on here again. On that side. And on that side. Now then, I'm going to turn on that. The meter has to go up a bit higher. There's nothing about there, so I'm going to turn on that. As you can see. Hey. And this tells me it is 28. And I take 28 from the top here, 28, and it's, do I have the right one? Have a look. That's the second one there. 28, and it tells me it is 87 microhenries. Yeah, 78 microhenries. That's what it tells me. It could be on I think about 30, it's a bit higher. 30, 74, 70, I think it's about 74 microhenries. This little coil. So you can see, you can measure any coil you can measure with that, provided you are within the range. Our maximum range here, because I miss another band here, there should be a band here, and there should be another band there, that's in total of 6. Then I go up to millihenries on this side, but I can go up here until, have a look, 612 microhenries. That's the max I can measure with the first one. Yeah, and the max what I can measure with the outside one is 1.7. So there's one put from 612 microhenries until 1.75 microhenries I can measure with this meter. So provided I find another switch in the near future with 6 positions, so I can fix on the frequencies, also the frequencies, then I will be able to measure or get it all lined up again, as this here and that one. So I will be able to measure then a half microhenry or something like that. I don't really see the point, because you know you're never going to in practice, you know, you're never going to make that. So, or even measure one of 10 microhenry, something like that. But it is a bit better. I can show you. Hold on. It's possible to do that kind of thing, you know. Let's have a look where that coil is. You can make them yourself. See, this one here is, I believe, is 1.4 microhenry. You see what an enormous coil that is? see, it is possible to get some plastic formers, stick them together with tape, and as I said, you wind that up, and this is more strands, copper strands in there. To make this kind of coil, I used the wrong lids. I used the wrong lids. You never should use something like that. I don't know the thickness in English, but I know it's about 0.3 millimeters. You shoot one strand, and then you wind them there. You get the more higher self-inductance. Anyway, guys, this coil works perfectly. You know, you put them in power supplies or something like that, just to prevent that high frequency RF gets into your power supply. That's what I'm using this for, or in a transmitter for that matter. I have built our Olga power set. I have one of them in there to prevent RF to get into the power supply. So anyway, guys, you can see what you can do if you put your mind to it. This works perfectly. I'm very satisfied with it. So I go up to my next project. I will inform you about later. I have an idea about that. It has to do with band split. Anyway, I think it was a bit similar apparatus as this one is. Similar. I have to think about that because it's not that easy, you know. You have to understand how band split works. And obviously you have your tuning capacitor, and you have your oscillator, which you need for that, your tuning capacitor, and your coil. And as you know, there's a certain value of microhenries and a certain value of picofarad of your tuning capacitor will determine which frequencies you are. And if you're in an amateur band, say in the 80 meter band, 3.5 until 3.8, then it's only a small part of that band which you want to use. If you use the coil as it is, then you probably have something from 3 megahertz until nearly 8 megahertz. So you see my point. You have a lot. You can actually cover 2 bands with it. It's not recommended. You should always use using only one for one band, because your tuning will be off if you try to do that. So I've done it in the past to make from it is possible, quite possible. My first receiver what I built, that was the B40, the Murphy B40. I built that myself, and I made a sort of band spread on that as well. So band spread is achieved by a series capacitor and a parallel capacitor, and they have to be working close together to achieve 3.5 and 3.8. So there are different values for that, depending on your tuning capacitor, of course. If you have a big tuning capacitor, the values will be different as if you use a smaller capacitor. If you think about your frequency stability, you always should choose a big capacitor as possible, because more capacitance, more stable that set will be. Okay, I'll leave it at that, and I will shut off this project, and I will wish you all the best, and I'll see you the next time. All right.